Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter Summation of Trigonometrical series by C+iS method, lecture number 5, in which I will solve all those problems such that C+iS is a Gregory series. Now we solve a problem. Problem is sum the series x cos theta minus x cube by 3 cos 3 theta plus x to the power 5 by 5 cos 5 theta minus dot 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 dot. Now we solve this. Let C equal to x cos theta minus x cube by 3 cos 3 theta plus x to the power 5 by 5 cos 5 theta minus dot 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 dot, and s equal to x sin theta minus x cube by 3 sin 3 theta plus x to the power 5 by 5 sin 5 theta minus dot 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 dot. This is number 1. This is number 2. Therefore, C plus IS equal to x, here cos theta, plus here I sin theta minus x cube by 3, here cos 3 theta plus I sin 3 theta plus x to the power 5 by 5 cos 5 theta plus I sin 5 theta minus dot 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 dot. This is equal to x cos theta plus I sin theta is e to the power I theta minus x cube cos 3 theta plus I sin 3 theta is e to the power I 3 theta by 3 plus x to the power 5 cos 5 theta plus I sin 5 theta is e to the power I 5 theta by 5 minus dot 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 dot. Let this is number 3. Let x e to the power I theta equal to y. This is number 4. Then 3 may be written as C plus IS equal to y minus y cube by 3 plus y to the power 5 by 5 minus dot 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 dot, and this is Gregory series, that is, this is tan inverse y. This is equal to tan inverse y means x e to the power I theta. This is number 5. Therefore, conjugate C minus IS. In place of I, we write minus I. Tan inverse x e to the power minus I theta. This is number 6. adding 5 and 6, we get here plus is and minus is cancel. That means 2c equal to tan inverse x e to the power I theta plus tan inverse x e to the power minus I theta. This is equal to tan inverse x e to the power I theta plus x e to the power minus I theta by 1 minus x e to the power I theta multiply x e to the power minus I theta. This is equal to tan inverse, we take common here x e to the power I theta plus e to the power minus I theta. Here 1 minus x multiply x square e to the power I theta minus I theta. This is equal to tan inverse x e to the power I theta is cos theta plus I sin theta plus cos theta minus I sin theta by 1 minus x square e to the power 0 is 1, implies that 2c equal to tan inverse x multiply here plus I sin theta minus I sin theta cancel 2 cos theta plus cos theta 2 cos theta by 1 minus x square, implies that c equal to half tan inverse 2x cos theta by 1 minus x square. This is the required answer. Now we solve the next problem. Next problem is cos square theta minus 1 by 3 cos cube theta cos 3 theta plus 1 by 5 cos to the power 5 theta multiply cos 5 theta minus dot 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 dot. Sum the series. Now we solve this problem. Let c equal to cos theta multiply cos theta minus 1 by 3 cos cube theta cos 3 theta plus 1 by 5 cos to the power 5 theta multiply cos 5 theta minus dot 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 dot. S equal to cos theta multiply sin theta minus 1 by 3 cos cube theta sin 3 theta plus 1 by 5 cos to the power 5 theta sin 5 theta minus dot 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 dot, implies that c plus is equal to cos theta common here cos theta here I sin theta plus I sin theta minus 1 by 3, we take common cos cube theta here cos 3 theta plus I sin 3 theta plus 1 by 5. We take common cos to the power 5 theta cos 5 theta plus I sin 5 theta minus dot 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 dot. This equal to cos theta plus I sin theta is e to the power I theta minus 1 by 3 cos cube theta. This is e to the power I 3 theta plus 1 by 5 cos to the power 5 theta. This is e to the power I 5 theta minus dot 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 dot. Let this is number 1. Let cos theta multiply e to the power I theta equal to x. This is number 2. Therefore, 1 may be written as C plus IS equal to here x minus x cube by 3 plus x to the power 5 by 5 minus dot 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 dot. This is Gregory's series, implies that C plus IS equal to tan inverse x. This is equal to tan inverse x means cos theta e to the power I theta. Let this is number 3. Taking conjugate C minus IS equal to tan inverse, in place of I we write minus I cos theta e to the power minus I theta. This is number 4. Adding 3 and 4 we get plus IS minus IS cancel, remains 2C equal to tan inverse cos theta e to the power I theta plus tan inverse cos theta e to the power minus I theta. This is equal to tan inverse cos theta e to the power I theta plus cos theta e to the power minus I theta by 1 minus cos theta e to the power I theta multiply cos theta e to the power minus I theta. This is equal to tan inverse. We take common cos theta. Here remains e to the power I theta plus e to the power minus I theta. Here 1 minus cos theta multiply cos theta, cos square theta, and e to the power I theta minus I theta. This equal to tan inverse. Here cos theta, here e to the power I theta is cos theta plus I sin theta, and e to the power minus I theta is cos theta minus I sin theta. by 1 minus cos square theta e to the power 0 is 1. Here plus I sin theta minus I sin theta cancel, implies that 2c equal to tan inverse, here cos theta, here cos theta plus cos theta, 2 cos theta, cos theta multiply 2 cos theta by 1 minus cos square theta is sin square theta. This is equal to tan inverse 2 cos square theta by sin square theta, implies that C equal to half tan inverse 2 cos square theta by sin square theta is cot square theta. This is the required answer. Now we solve the next problem. Next problem is if u equal to cos alpha minus 1 by 3 cos 3 alpha plus 1 by 5 cos 5 alpha minus dot 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 dot, and v equal to sin alpha minus 1 by 3 sin 3 alpha plus 1 by 5 sin 5 alpha minus dot 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 dot. Then prove that number 1 u equal to pi by 4 and cos hyperbolic 2v equal to sec alpha. Number 2 tan alpha equal to sin hyperbolic 2v multiply cosec 2u. Now we prove this. Solution. Since u plus iv equal to cos alpha plus I sin alpha minus 1 by 3 cos 3 alpha plus I sin 3 alpha plus 1 by 5 cos 5 alpha plus I sin 5 alpha minus dot 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 dot. This equal to cos alpha plus I sin alpha is e to the power I alpha minus 1 by 3 cos 3 alpha plus I sin 3 alpha is e to the power I 3 alpha plus 1 by 5 cos 5 alpha plus I sin 5 alpha is e to the power I 5 alpha minus dot 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 dot. Let this is number 1. Let e to the power I alpha equal to x. This is number 2. Therefore 1 is written as u plus iv equal to x minus x cube by 3 plus x to the power 5 by 5 minus dot 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 dot. This is a Gregory series. Therefore u plus iv equal to tan inverse x. This is equal to tan inverse x means e to the power I alpha. This is number 3. Since modulus of e to the power I alpha equal to 1 implies that modulus of x equal to 1. This is since. So this is a Gregory series. Implies that we take conjugate u minus iv equal to tan inverse e to the power minus I alpha. This is number 4. Adding 3 and 4, we get 2u equal to tan inverse e to the power I alpha plus tan inverse e to the power minus I alpha. This is equal to tan inverse e to the power I alpha plus e to the power minus I alpha by 1 minus e to the power I alpha multiply e to the power minus I alpha. This is equal to tan inverse. Here e to the power I alpha is cos alpha plus I sin alpha. This is cos alpha minus I sin alpha. E to the power minus I alpha means cos alpha minus I sin alpha by 1 minus e to the power I alpha minus I alpha. This is equal to tan inverse. This is plus I sin alpha minus I sin alpha. Cancel. 2 cos alpha. Cos alpha plus cos alpha. Here 1 minus e to the power 0. This is equal to tan inverse 2 cos alpha by 1 minus 1. This is equal to tan inverse 2 cos alpha by 0. This is tan inverse infinitive. This is equal to pi by 2. Implies that u equal to pi by 2 by 2 means pi by 4. This is number 5. Subtracting 4 from 3, we get u plus iv minus u minus iv. This is equal to tan inverse e to the power I alpha minus tan inverse e to the power minus I alpha. Implies that this is 2iv equal to tan inverse. This is e to the power I alpha minus e to the power minus I alpha by 1 plus e to the power I alpha multiply e to the power minus I alpha. This is equal to tan inverse. This is e to the power I alpha is cos alpha plus I sin alpha minus this is cos alpha minus I sin alpha by 1 plus e to the power 0. This is equal to tan inverse. Here cos alpha plus I sin alpha minus cos alpha plus I sin alpha by 1 plus 1. This is equal to tan inverse. Here cos alpha cancel. 2i sin alpha by 2. This is tan inverse I sin alpha. 2 cancel, implies that tan 2 here I v equal to I sin alpha, implies that this is I tan hyperbolic 2v equal to I sin alpha, implies that I cancel, tan hyperbolic 2v equal to sin alpha. Let this is number 6. Since sec hyperbolic square 2v equal to 1 minus tan hyperbolic square 2v, this is equal to 1 minus sin square alpha, this is cos square alpha, implies that sec hyperbolic 2v equal to cos alpha, implies that 1 by cos hyperbolic 2v equal to cos alpha by 1. Cos alpha means cos alpha by 1, implies that cos hyperbolic 2v equal to 1 by cos alpha, implies that cos hyperbolic 2v equal to sec alpha, and this is proved. This is number 1 proved. This is the second part proved. Now for number 2, let this is number 6. Since from 5 u equal to pi by 4, implies that 2u equal to 2 multiply pi by 4, implies that sin 2u equal to sin 2 cancel pi by 2, this is 1, implies that 1 equal to 1 by sin 2u, implies that this is cosec 2u, cosec 2u equal to 1. This is number 7. Since cos hyperbolic square 2v minus sin hyperbolic square 2v equal to 1, here we have cos hyperbolic 2v equal to sec, this is sec square alpha minus sin hyperbolic square 2v equal to 1, implies that sec square alpha minus 1 equal to sin hyperbolic square 2v. This is tan square alpha equal to sin hyperbolic square 2v, implies that sin hyperbolic 2v equal to tan alpha. This is number 8, implies that tan alpha equal to sine hyperbolic 2v multiply 1, and in 7 1 is sine hyperbolic 2v cosec 2u using 7 and proved. Second part proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button, and if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.